In this video, we'll begin the process of adding new components to our printer. Our starting point will be the 3D printed part that we'll use to mount the board. You can find the STL file link, as well as links to all the components used in this video, in the video description. To install the board on the mount, we need to begin by adding 4 M3 threaded inserts. I used a soldering station and set the temperature to 230 degrees Celsius, the melting temperature required for PLA. Then I applied pressure to push the insert into place and used a hex key to ensure the insert was flush with the hole. While it's possible to skip using threaded inserts, I recommend using them. Without threaded inserts, your board, when installed, is more likely to be loose, and we need it to be securely in place. In the first part of this video, we'll be focusing on the SKR3 board. I'd like to emphasize the importance of using the links provided in the video description. By doing so, you not only support the growth of our channel, but also ensure that you receive the correct parts. The SKR3 board comes in various types, including the SKR3 EZ and the standard version, among others. In the disassembly video, when we removed the board from the electrical box, I mentioned the importance of keeping the screws. Now we'll be using those screws to install the mount that will allow us to securely install the SKR3 board. Before we go any further in the video, I want to ensure that you're aware of our Discord server. You can find the link in the video description, and it's an essential resource throughout this upgrade process. It's a valuable community where you can seek help, share ideas, and even get assistance in real time, including from me. Subscribing to the channel is not only beneficial for me as it helps the channel grow and potentially collaborate with other printer projects, but it's also advantageous for you. Subscribers will be notified of new video uploads, ensuring you don't miss any updates. I'm currently unboxing the SKR3 board, and I must say, it's a fantastic board. It's the only option I would strongly recommend for this particular printer, and I've explained the reasons for this in previous videos. One of the key advantages of this board is that it comes with 5 stepper driver slots, allowing us to independently control each stepper motor. We'll be using UART. To enable UART, we need to remove the first, second, and fourth jumpers, leaving only the third one in place. Unfortunately, I didn't have tweezers on hand, so I had to use pliers. However, I strongly advise against using pliers, as they can potentially break the jumpers or cause other issues. I did it because I have experience with moving these jumpers, making it less risky for me. Nonetheless, I want to emphasize that extreme caution is necessary when performing this step. For each stepper driver slot, follow the same procedure. Starting from the top, remove the first one, the second one, keep the third one in place, and remove the fourth one. Repeat this process for all the slots, and then you can proceed to the next step. As shown in the video, take your time during this process and ensure you're using the appropriate tool. Installing the stepper drivers is straightforward. Notice the red section at the bottom of each driver, and conveniently, there are corresponding red marks on the board. Align the red sections on the drivers with the red marks on the board, much like fitting Lego pieces together. If your driver doesn't come with a heatsink already installed, you can easily attach one by peeling off the protective tape and placing it on top of the driver. You'll need to install a total of 5 drivers, as we'll be using all 5 stepper motors. Keep in mind that the red section should align with the red marks on the board, while the other side is black. I'll be using a custom PCB that I created, although it's not a necessity. I designed it for the flexibility of easily removing or modifying parts. However, it's important to note that you don't necessarily need this PCB. If you want to achieve a similar result, there are various alternative methods to explore. Now let's discuss the connections. The first cable I'm plugging in is one of the 2 connectors for the BL Touch probe. BL Touch has 2 parts, the probe and the servo. The cable with 2 connectors is for the probe, while the one with 3 connectors is for the servo. Simply connect them, and you're good to go. The next 2 cables are for the fans. We'll use the number 1 fan slot and the number 3 fan slot. These fans will serve as the part fan and the cooling fan. Plug the first fan into the first slot, and for the second fan, use the third slot. Following the same configuration for the fans will indeed simplify the process because you will not need to edit the printer configuration file of Klipper yourself. Instead, everything is going to be set up correctly automatically. This cable is for the Hotend thermistor, which measures the Hotend temperature. The last cable is for the Hotend, and I've used a 4-connector pin. However, I'm only using 2 of them, with 1 space between them. I did this to prevent them from touching each other. Additionally, I've installed ferrules on the other end of the cable to enhance safety and prevent potential issues in the future, such as loose connections or cable contact. The next step involves connecting the Hotend cables to the board. On the board, you'll notice it's labeled as EO, and you should look for the third slot from the right, which corresponds to this label. Now, here's the good news. When connecting the Hotend, polarity isn't a concern. It doesn't matter which wire goes where in terms of positive and negative, as both wires serve resistive functions. Ensure that the connection is made securely, and when tightening the screw, make sure it's tight enough so that the cables won't budge or come loose. This is important because, as I mentioned earlier, loose connections can pose potential risks. From this point onward, I will begin connecting the cables we created in the previous video. These cables will be connected in a specific order, starting with the top one, which is designated for the 2Z motors and is furthest from the electrical box. The second slot is designated for the extruder, which matches the cable we created specifically for the extruder. Regarding the 2Z motors, we already plugged into the E1 slot the first motor's cable. This choice is made because we're using a dedicated stepper driver for each Z motor. If you examine the pinout of the SKR3 board, you'll notice there are Z and Z1 slots, but we will use only of them because Z and Z1 share the same stepper driver. For this reason, we'll skip one slot and use the next one, which will be for the other Z cable, the shorter one. After that, we'll move on to the Y cable, which will be the next one to be plugged in. Ensure that the orientation of the board is the same. Once you've connected the Y cable, the final cable to be plugged in is the X motor cable. This cable will go into the last available slot, and our earlier marking of each cable will make the process much smoother. Now, I'm going to place the board inside the electric box. It may look a bit messy at this point due to the numerous cables, but we're not done yet. We need to reconnect the bed thermistor, which is labeled as T1. This thermistor should be plugged in right next to the Hotend thermistor. As you'll see, it's located close to the Hotend thermistor's connection point. Just plug it in, and you're good to go. The next cable we'll deal with is one I made myself, because the original one was quite terrible. I created a new cable and added ferrules at the end. This ensures that there's no chance of the cables escaping from their connections. We are dealing with the bed control cable connected to the MOSFET. Here, polarity matters. If you follow the correct color pattern, the black cable represents the negative, and the red one represents the positive. In this case, the black cable is on the right side, as shown in the video. Ensure that the orientation matches. Moving on to the DC in, this is where the board receives its power. This time, the positive cable will be on the right, and the negative cable will be on the left. This might seem like a reversal, but it seems to be a safety feature applied by the manufacturer to avoid confusion. In any case, the red cable goes on the right, and the black cable goes on the left. For these connections, there are fair rules already added, so you don't need to worry about them. With these connections completed, everything should be properly plugged in. The next step is to secure the boards in the mount that we created earlier. Finally, you can reassemble the Z-axis. By tightening the bolts and screws on the bottom, the printer will start to look more like a complete unit, even though there is still a lot of cable management and connection work to be done. The first cable I'll be connecting is the Z stepper motor cable. The top cable is for the Z motor on the left side, which is the longer one because it's farther away from us. The second cable to connect is the Y cable, which goes to the Y stepper motor at the back of the printer. I'm using cable sleeves to keep everything neat and organized. Next, I'll connect the Z1 cable. This one goes to the right side of the printer when looking at it from the front. It's the shorter cable of the two Z cables. Plugging in the Z1 cable is a straightforward process, as you can see in the video. Now, while the printer is still in this orientation, I'll begin the installation of the metal Y-belt tensioners. These were sent to me by King Rune, and you can find a link to purchase them in the video description. King Rune is a great shop with reasonable prices. This upgrade is fantastic because the Y-belt tensioner, as well as the Xbelt tensioner, are made of plastic and can be quite problematic. They are prone to breaking and can even snap the belt. So, while the printer is in this position, I'll remove the plastic tensioners and replace them with the metal ones, which is a significant upgrade. Since we have 2 Y aluminum extrusions, we'll need 2 metal tensioners. You can find the link to the shop in the description to purchase the same parts, to ensure you get the right ones. Installing them is straightforward. You'll need to screw certain parts into the aluminum extrusion where they'll fit snugly. You don't need to tighten them all the way initially, just enough so they can slide in. Once they're inserted, you can tighten them down securely, ensuring they won't move. This connection is solid, and it's not too difficult to accomplish. It takes a few minutes to ensure they fit properly, but once they're in, you can tighten them down. It's essential to get them quite tight, as you don't want the tensioner itself to move and cause issues. After doing this for one side, you'll need to repeat the operation for the other side. I would like to sincerely request that you subscribe to the channel. It's crucial for the channel's growth and will allow me to create more similar videos in the future. When a channel becomes relevant in the industry, companies are more likely to collaborate and provide opportunities for creating valuable content. By subscribing, you not only gain access to free content, but also help in building a community where people can provide assistance and support on various topics in the Discord channel. Your subscription and participation are greatly appreciated. I'm currently installing the other metal belt tensioner, and I've included close-up shots to make it easier for you to follow along. It's a straightforward upgrade. Just slide it inside the extrusion and tighten the screws. This upgrade makes a significant difference, especially in the long run, as many people have complained about the plastic belt tensioners breaking. It's worth noting that the new Kobra Max 2 printer has been announced, claiming impressive speeds. It would be interesting to compare our modified printer to their new model. If you share this video with others who are interested, there's a chance that Anycubic may be interested in collaborating for such a comparison. You never know. I purchased this sleeve for the printer, which is fantastic because it's not the type that looks like snakeskin. It's much better. For this step, we'll need to use the X and E cables, as well as the larger cable we made to keep all the Hotend components together. This sleeve makes cable management much easier, especially given the large number of cables involved. With this type of sleeve, you simply open it and then slide the cables in. It rolls back over them, securing them neatly. It's far superior to the traditional sleeves that are cumbersome to use. As you slide the cables through, you'll notice that the X-axis cable is shorter because it's for the X motor. Leave it outside temporarily so you can plug it into the motor. Continue sliding the rest of the cables through until there are no more left. Now, I'm going to cut the sleeve, leaving it a bit longer just in case I need extra length for any unforeseen issues. We still have some cable management challenges to figure out, such as how to efficiently handle this large cable. It's quite bulky, and we need to position it between the rods and the aluminum extrusion. There are so many cables that using clips to secure them in place is challenging. Now I'm plugging the big cable into the electric box. One thing to keep in mind is that there is exposed metal in that area, so it could potentially make contact with other components. I attempted to upgrade the Xbelt tensioner as well, but I ran into some difficulties. Initially, I wanted to remove the Xbelt tensioner completely to install a metal one that King Rune sent me. However, I encountered a problem during installation. It turns out that this 2020 profile only has 2 V-slots instead of 4, which posed a significant challenge. In the end, I had to reinstall the original part. Now I'm in the process of disassembling the Hotend because I won't be using the stock Hotend. It's not ideal, and I prefer to use the Anycubic Chiron Carriage one. To do this, you'll need to follow a somewhat tricky process. First, you have to remove the 4 screws that hold the plastic parts in the front. Once you have access to this, you need to remove the actual Hotend inside. Afterward, you'll have to remove the PCB to access the carriage screws. So, I'm working my way through this process. In the video, I'm removing the 2 screws on the top where the Hotend is installed. Once these screws are removed, you can pull the Hotend down, and it will come off. I'm being careful not to damage any parts, even though I won't be using them in the future, as it's a good practice not to damage components during disassembly. As I mentioned earlier, you need to remove the PCB. In my case, one of the screws was loose, so I had to use a glove to get a better grip and unscrew it. This trick can be handy when dealing with loose screws. Now, you can remove everything by using a number 8 tool to unscrew the mount. Focus on the 2 screws on top because once you loosen them, the assembly will become free to move, allowing you to remove it. Don't forget to remove the belt. Simply slide it out to detach it. This is the Chiron carriage, and I'm using it because I really like it. Someone designed a mount for the Hemera Revo a few years ago, and I appreciate its design, so I'll stick with it. However, during the video, I realized that I couldn't mount the metal tensioner for the X-axis without making some holes, which I might do in the future. For the purposes of this video, I didn't drill any holes in the extrusion. Keep in mind that creating a video like this is time-consuming, especially with camera movements. I had to work quickly because it was a lengthy process, spanning a couple of days of recording. Please note that when someone like myself makes a video, it takes more time than a typical installation. As you can see in the video, I'm reinstalling the plastic tensioner, which I'm not thrilled about, but it's what I had to use. Because the Chiron mount is smaller than the Kobra's, I had to use a zip tie on the mount itself to apply enough tension for the carriage to move without skipping steps when moving at high speeds. This was necessary to make it work. The last step is to mount the actual hemera. If you're interested, I'll leave a link to the specific file, but please note that it won't work with the stock carriage. You may not find this carriage available for purchase either. However, if the community grows in the Discord channel and more people join, it's possible that someone will remix this and make it compatible with the stock carriage, which would be great. For now, the only way to make it work is by using the Chiron carriage, which is easy to mount and quick to switch. I won't be mounting the cooling part of the fan just yet. I'll do that later because I want to first test some of the machine's parts. It's a straightforward process. There are 2 screws to secure it to the carriage, and then there are 2 screws for the Hotend fan. Now, I'll plug in the PCB I made. You don't necessarily need this because you could create a plug that goes from the board all the way up here. Instead of using the JST connectors, you could use a different type of connector like Molex. This can make the connections cleaner. I'm still working on a system of drag chains, but I ended up discarding the idea for this video due to time constraints. However, I plan to cover drag chains in a future video. For now, there won't be any drag chains in this setup. Finally, I'm plugging in all the PCB components and I'll connect the extruder motor. That concludes this video. In the next video, we'll be installing Klipper. Please remember to subscribe to the channel, click the notification bell icon, and join the Discord server to get more help from me and other members of the community. Thank you for watching.